Perform the operations. Write the answer in the form a plus bi. So first I want to address why this problem looks so scary, and that is the fact that we have radical signs with negative numbers below them. So in order to address this problem, we're going to use our handy dandy friend, the letter I, whose value is the square root of negative 1. So I'll walk you through each negative radical here and show you how the letter I will give us a problem we can actually solve. So the square root of negative 9 can be rewritten as the square root of positive 9 times the square root of negative 1. Remember, I is equal to the square root of negative 1. So what we've really got is the square root of 9 times I, and the square root of 9 we know is 3, and then times I. So this value gets replaced with 3I. And this minus sign stays because although we got rid of the one inside the radical, this one just goes straight down there. And then we've got the square root of negative 4, which we can also use I to simplify. So we've got the square root of negative 4, rewrite it as the square root of positive 4 times the square root of negative 1, which happens to be the letter I. So we've got square root of 4 times I. Square root of 4 gives us 2 times I. So that's what we'll replace the square root of negative 4 with, plus 2I. So now this expression becomes much more simple to solve. First thing I'm going to do is distribute this negative sign. So we have 7 minus 3I minus 4 minus 2I. And then we're going to combine like terms. So we've got 7 minus 4 gives us 3, and then negative 3I minus another 2I will give us minus 5I. And once we get it as simple as it gets, we're going to check to make sure we have it in the correct form of a plus bi, which indeed we do. Here we've got 3 is a. I know it says plus, but we're technically adding a negative 5, so that becomes our b times I. So it's in the correct form, and our final answer is 3 minus 5I.